So for this problem, we're going to prove that the sum of the first n terms of an arithmetic series is given by n over 2 times 2a plus n minus 1 times d. So this is a very important proof and it must be learnt for the exams, okay, so it can be in the A-level exams, okay. So the key to start this out is to actually write out what the summation means. So if we're looking for the sum of the first n terms, well, our first term is given by a. The second term of an arithmetic sequence would be given by a plus the common difference. So because we're looking at an arithmetic series, we're going to add that on. Plus a plus 2 lots of that common difference. Plus, and so on, until we get towards the nth term and we can say that we have a plus, say, n minus 2 times that common difference, plus, and then when we hit our nth term, a plus n minus 1 times that common difference. We have this n minus 1 because the original expression doesn't have any d's in there because we start at a, so the nth term is going to have 1 less d than the n number of d's. So we can write out all the terms. Write all terms. We then need to write out a very similar expression, but actually we need to reverse this. So we can also say that our summation for the nth term, we can start with the expression for the nth term, a plus n minus 1 times d, plus a plus n minus 2 times d, and so on, to a plus 2d plus a plus d plus a, which is back to our first term. So write all terms in reverse. So we have expression 1 and expression 2 there. And what we need to do is we need to add these two together. So we're going to add 1 and 2. If we do that, we're really going to get 2 times our summation. Now, if we add our first term and our nth term together, we're going to have 2a plus n minus 1 times d. Well, when we add the second term and the n minus 1 term together, again, we're going to have 2a plus n minus 2 lots of d plus a d, which gets us the n minus 1 lots of d. Same again with the third and the n minus 2 terms, and so on. So each term is going to have a matching term until, really, we have n lots of terms there. So we're going to multiply that by n because there are going to be n terms, because that's the summation that we're looking at. So the final stage, really, we've done all the hard work, is to get a singular version of the sum of the first n terms, is to divide by the 2, which is where we get the n over 2 times 2a plus n minus 1 times d. And that is how we generate the summation formula for the first n terms of an arithmetic series. And as I say, this is something that must be learnt for the exams because they can ask you to prove that formula.